Here we're going to do a second completion of the square to get vertex form with a more straightforward one. And I'm going to go through just some systematic steps. I'm going to use number 2 from the completion of the square vertex form homework that I gave in C and E blocks yesterday. So it says y equals x squared minus 2x minus 5. The first thing I can do is I can get the y-intercept. The y-intercept is what y is if x is nothing. So that means I'm just going to copy this equation down here. Get rid of my automatic page numbering. And now I'm going to make x equal to 0. So if I make x equal to 0, that goes away. And negative 2x goes away. So all I'm left with is 5 when x is 0. So my y-intercept is 0, negative 5. I've got a point. Now we're going to complete the square. So we've got our, I'm going to go ahead and put this on a new page so I'm not having to go back and forth between pages. So I've got x squared minus 2x minus 5. And that equals y. So what I need to do is I need to figure out some way to make the x squared minus 2x into a perfect square. So I'm going to, without changing the side of the equation, so I want to arrange this so that it's going to be easy to turn into vertex form. So I'm going to take half of negative 2 and square it. Well, that's just positive. That's just going to be negative 1 squared. So that's going to be negative 1 squared in there. And that's just positive 1. So I don't care about all that. So, but if I add 1 in there, I have to subtract 1 there as well. So if I'm doing that, then I'm going to end up with y equals the second factor. I can factor that into x minus 1. It's minus because this is negative. If you're unsure about that, go back and review the perfect square special case. It's really important to be familiar with that. And minus 5 minus 1 becomes minus 6. So I now have my vertex. My vertex is given to me by this h value, which is 1, and this k value, which is negative 6, because it's plus k, so that's plus negative 6. Negative 6 is my vertex. So 1, negative 6 is my vertex. Now, I can figure out my mirror point. My mirror point to the y-intercept, well, the y value will be negative 5. Now I got to figure out the x value. To get to the x value, I'm going to go halfway across the parabola to the middle, which is going to get me to an x value of 1. So I go 1, and then 1 more to get there, and now I have my mirror point. I want 2 more points, and in this case, usually I've been picking my 2 more points as being something between the vertex and the y-intercept and the mirror point. In this case, I'm going to go outside because otherwise I'm going to have to deal with fractions. And if I can do this without fractions, I'll do it without fractions. If I had to do it with fractions, I would, but I don't have to, so I'm not going to. So I'm going to pick a point on the other side of 0 from our vertex. So I'm going to pick negative 1, comma, something. And I'm going to also pick something on the other side of 2 from 1. So I'm going to pick a point at 3, comma, something. And I'm going to I could plug this into my original equation, or I can plug it in here. I find it a little easier to simplify it if I plug in my inputs into the vertex form. So I'm going to do that. I'm going to say, okay, my vertex form is x minus 1 squared minus 6. Do that so I can use it again. So for an input of negative 1, or an input of 3. So I'm going to figure out what my output is for each of those inputs. So -1 minus 1 is -2. Okay, over here, 3 minus 1 is +2. Well, look at that. I've got a -2 squared and a +2 squared. Both of those are going to give me 4. -2 squared is 4. 2 squared is 4 also. So I'm going to end up, as you can see, with the same thing. 4 minus 6 and 4 minus 6, which is -2, and that's the same thing. So that's also -2. So my y value here is -2. -2 again. And so now we're going to plot those points. So I've got a vertex at 1, -6. And I'll clear this stuff out. I'll leave that there for reasons. And I'm going to say 1, comma, -6. And then I had a y-intercept at 0, -5. 0, -5. And a mirror point at 2, -5. I'm going to move my graph around a little so you can see this actually happening. Okay. And then I had a point at -1, comma, let's remind ourselves what it was. It's -1, -2, and 3, -2. And now we'll plot our parabola. Our parabola was originally x squared minus 2x minus 5. So y equals x squared minus 2x minus 5. And it matches very nicely. That will also match with our vertex form of y equals x minus 1 squared minus 6. And that matches too. If I zoomed in, those would be exactly the same thing. All right, I'm going to close this right now, and we're going to do this the sneaky way. All right, now the sneaky way is pretty easy to see because it matches up with what we've been doing. So we're going to use a pattern with the vertex at the center. So the pattern of this one is going to be governed by the fact that our a value is just 1. So that's a 1. So we're going to match the usual pattern of a parabola. So I'm going to go ahead and go in here, plot our vertex at 1, -6 again. So we've got a vertex at 1, -6. I'm going to go from here over 1, up 1. So I'm going to have 2, comma, -5. I'm going to go over 1, up 3 this time. So I'm going to over 1, up 1, over 1, up 3. It'll be over 1, up 5, then 7, then 9. So now I'm going to go over to 3, and I'm going to go up 3 more this time. So I'm at -2. And I'll go ahead and do one more. So I'll go up 1, up 3, up 5. So I'll go over 1 more to 4. And now I'm going to go up 5 from -2. I'm going to go to 3. And why not do one more? Over to 5. And in this case, instead of going up 5, I went up 1, 3, 5. Now I'll go up 7. So 3 plus 7 is 10. And these would match on the other side as well. So I would also have at 0, -5, and then -1, -2, and -2, comma 3, and -3, comma 10. And you can see it's kind of parabola-y in its shape, and we can plot it, and it matches. It matches with this. And that, my friends, could save you some time when you're graphing these things. So that will work just as well. I'm going to pause this one. I'm going to stop this one, and I will then